Now see here beta decay. Beta decay already I have seen beta particle is taken as -1, that is this one electron is taken as beta particle. But you know the beta positive and beta negative both can come out. So we can take also here +1 E0, that is called electron here and this is called positron. So both the emission can take place. Suppose you have taken any nucleus X whose atomic number Z and mass number is A and it is emitting the beta particle here, that is -1 E0, then we can take, mass number is actually negligible here, then we can take the daughter nucleus as Z plus 1 and A remains as it is. But if you are taking emission of the positive beta particle, that is ZA, then you can take here +1 e raised to power here 0, then you can take here y z minus 1 and a. In both the cases, the negative beta decay or the positive beta decay, in both the cases, here mass number remains same, but in negative case atomic number increases by 1 and in the positive case atomic number decreases by 1. Let us take example of this. In this example we can take here, if you are taking here like a phosphorus that is 1532, when it emits, you know, like a beta particle -1, new element is formed S, that is sulfur here, that is 16 and 32. But here neutrino comes out, that is called antineutrino. So antineutrino has got a negligible mass, no charge, but it has high energy. Because of it, this property it cannot be detected easily. So this one is here, this is a negative beta decay. If you are taking the positive beta decay, that is called positron, then we can write Na, that is 22, it gives out here +1 E0, here the neutrino comes out. And then we can write here Ne here, this is here 10 and 32. Here atomic number is reduced by 1 and mass number remains same. But see here during the beta emission always the neutrino particles are emitted, and you know the low energy beta particle comes out with the high energy neutrinos and high energy beta particles are coming out with the low energy neutrinos. When we draw the graph between the kinetic energy of the beta particle and number of the beta particles here emitted, so here the beta particles and here is the kinetic energy, then the graph comes out to be this. This is called endpoint energy. It means in this process beta particles of all possible energies are emitted. So there is no violation of the conservation of energy because low energy beta particles are carried away with the high energy neutrino and high energy beta particles are coming along with the low energy neutrinos. So this is the graph here. So actually the beta emission is a continuous one because there is a beta particles of all possible energies are emitted. Now also if you take how does beta particle comes from the nucleus. So you know the free neutron is unstable. If you have taken a free neutron like this 0 1, that disintegrates and forms here -1 0 plus antineutrino and it gives out a proton and whose is here 1 and 1. So the free neutron disintegrate itself, but if you take free proton also it can disintegrate, but it is not easily disintegrable. The reason is its mass is less. So it can come out with the here +1 E 0 and plus neutrino and here it is coming out 0 and 1. So proton also can disintegrate into the neutron. So this is about the beta decay. Now after the beta decay we can take here the gamma decay. So in gamma decay, see here, after the emission of beta particle or the alpha particle, nucleus is in excited state. So when the nucleus is in excited state, it emits energy in the form of the gamma radiation, that is the photons. That energy is equal to h nu. That is actually equal to the energy difference between the two states, like one excited state and the ground state if it is jumping to. And in that case if it is here x, this is Z A and it is emitting here the gamma like 0 0. So the atom remains same, nucleus does not change, atomic number remains same, everything, just its energy is here changing here. It means it is coming from one excited state to another one or maybe the one excited state to ground state. and we can get the energy released or the energy of the gamma particle, that is the difference between two energy levels. So, this is about the gamma decay. So, we have done in detail now the radioactive decay like alpha, beta and gamma radiations.